Hi guys, my name is Shane Orling, and I'm here to talk to you about the planet Saturn. Saturn is one of the most instantly recognizable planets in the solar system. It is the fifth from the Sun, apart from the red hue of Mars, which is affectionately, of course, known as the Red Planet. You'd be hard-pressed to find a planet more recognizable than Saturn, of course, because of its iconic rings. The history of Saturn, as it's been observed from Earth, is quite literally as old as time. I was shocked to discover this, but ever since the ancient eras of human history, I was aware that you, of course, can see Saturn from the surface with a naked eye. You can make out its movements. It's bright enough that you can tell what it is. If you want to see the rings, or if you want to see any of its hue, anything like that, you would need a telescope. Um, Otherwise, you can see it. And so, even since the ancient eras of human history, even since prehistoric times, Saturn has been studied and observed. Before even the invention of the telescope, Saturn was being studied by astronomers, and in prehistoric times, the Babylonians actually studied and recorded Saturn's movements. Of course, it was like a dollar store version of what we do today in studying and recording Saturn's movements. But anyway, as time moved on, moving away from ancient times in which the Greeks and the Romans studied Saturn, named it different things in their own ways. More about Saturn was actually discovered, and it kind of culminated in a watershed moment in Saturn's observational history when Galileo used a 15 millimeter telescope to finally discover Saturn's rings. Of course, technology wasn't perfect. Galileo mistook the rings for two moons on Saturn's sides, and literally you can look at this picture. This is from Christian Huygens, who eventually did discover that they were rings, but this first one here on the left, you can kind of tell they literally thought it was like crescent moons on either side of Saturn, like massive crescent moons. And it wasn't until the middle of the 17th century that Christian Huygens actually was able to use a telescope powerful enough to discover that the rings were, well, rings. And so since his landmark discovery, Saturn has been studied and analyzed and even visited a couple times to collect as much information as possible regarding its geological makeup and natural history. So I went through some of that. One of the more interesting facts I discovered regarding Saturn in the course of my research is that it's actually buoyant. I'm serious, just like a freighter. If you ever were to come across a pool with a surface area larger than 16.5 billion with a B square miles, that is the surface area of Saturn, if you were wondering, you could put Saturn in it and the planet would literally float. It is the least dense planet in the universe, in the solar system, excuse me. It's the only planet less dense than water, coming in at 0.69 grams per cubic centimeter compared to obviously 1 gram per cubic centimeter for water. And Earth is 8 times as dense as Saturn, despite Saturn being 95 times more massive. So when you think about Saturn's mass being that large, it's huge. You wonder then, why is the density so low? Well, it's because the majority of Saturn's mass exists at its core. And at its core, Saturn is more dense than water, because at its core, the heat, the pressure, the gravity, all of these different forces work together, and they turn the massive hydrogen presence in Saturn's gaseous makeup into actually a metal. Because as gases work, there is a physical state, a solid state, a liquid state, and a gaseous state. A lot of the hydrogen in Saturn is actually liquid. Um, it's a non-ideal liquid, but it's a liquid nevertheless. And at its core, it is metal hydrogen, solid hydrogen. The reason for its low average density, though, is because of its atmosphere being mostly gas and non-ideal liquids. Unlike the Sun, which is composed of 25% helium, Saturn is made up of just 3% helium and 96% hydrogen. The remainder of the atmosphere is made up of trace amounts of other gases: ammonia, acetylene, ethane, propane, phosphine, methane, gases like that. Saturn's cloud activity is typically due to these trace gases. That's the yellowish hue that you see. Comes a lot because of the relatively large amounts of trace gases that exist out on Saturn's outer atmosphere. That ammonia that you see, the acetylene, the ethane, the propane, the phosphine, the methane, these exist out in the outer atmosphere. And so that's kind of the coloring that typical, Saturn that you kind of imagine, that you see in movies, on pictures, things like that. And its cloud activity exists out in the outer atmosphere, typically because it's got such relatively low Kelvin temperatures. In fact, at the poles, I think it is a phenomenon that is exclusive to Saturn in our solar system, not in the universe, but it actually has a polar vortex that is the warmest point on the planet at negative 120 degrees Celsius. So very cold. It's like 100 degrees Fahrenheit. Saturn occasionally, it does have some fascinating storms the way that Jupiter does, but typically it's kind of more boring, and that is because the cloud activity is just made up of frozen ammonia crystals that kind of float above the gaseous compound and are pulled in by the gravity caused by Saturn's core. It does occasionally have some storms known as the Great White Spot, colloquially, similar to the Great Red Spot on Jupiter. They appear as like massive oblong ovals, cloudy looking things on the surface of Saturn. It also exhibits a phenomenon similar to one Earth exhibits, and this is one I found kind of interesting, in that Earth is not a perfect sphere, as we know. It's instead an oblate spheroid, meaning the distance from crust to core is slightly longer at the equator than it is at the poles. Saturn also has this phenomenon, but it's extreme because Saturn spins really, really, really fast as compared to Earth, as compared to a lot of planets, which makes it appear as a flattened ball because the distance from the core is about 6,300 kilometers longer at the equator than it is at the poles. Of course, anytime you talk about Saturn, the real moneymaker is what made, if you saw Christopher Nolan's film Interstellar, when Saturn comes on the screen, it's a really spectacular sight. And the reason for that is because the rings take up so much of the screen. It's obviously the most famous aspect of the planet's appearance. It's just a massive part of the planet itself, and the rings are among the most famous and unique sights in our solar system. However, I found this really interesting. They're a complete mystery. Nobody has any idea. They know what makes them up. They know a little bit of the compound. They don't know how old they are. The rings expand out from Saturn's equator up to a maximum of 75,000 miles. That's 10 times the diameter of Earth. You can put Earth on the rings 10 times before you'd fill up the entire ring. One interesting fact regarding the rings is, again, no one knows how old they are. They could both be extremely old or relatively young in terms of solar system age due to their icy makeup. One theory regarding the rings thinks that a massive ice moon was orbiting Saturn at one point and was ripped apart by Saturn's gravity, and the remains kind of scattered across the equator of the planet into rings. This would lead to the idea that they're relatively young, that a moon existed after the formation of Saturn, after the formation of the solar system, that it existed for some amount of time and eventually was weakened so severely by Saturn's massive gravitational pull that it was literally ripped into pieces. And those pieces scattered up in what would amount to a planetary explosion and built an orbit around Saturn. Another theory is that during the formation of the solar system, and this one posits more that the rings are very, very old, Saturn was formed, and the gravitational forces kind of disrupted leftover materials that existed in the solar system, causing them to form into, rings instead of a traditional moon. But anyway, as the composition of the rings goes, 93% grainy water ice particles, 7% amorphous carbons. So it's mostly like a physical, tangible thing. It's not really gases. It's these frozen water particles that just orbit the surface of Saturn, and that's kind of 93% of what makes it up. Grainy in the way they're almost like sand. Saturn has been researched and studied at length. Obviously, its composition makes it difficult to explore, sort of in the way that Venus is difficult to explore, in the way Jupiter is difficult to explore, and that these gas planets get really, really hot as you get towards the core, and also particularly Venus, but also it's just the heavy, heavy concentration of these gases makes it very difficult to make craft that can survive that. 2004 was actually the first time that any spacecraft were sent to Saturn for the purpose of visiting Saturn. When NASA sent the Cassini aircraft to orbit the planet, captured photographs of the surface, the rings, and its moons. And indeed, Saturn has over 60 moons, with over 50 of them named. One of its most famous is Titan. Consists of a hostile surface filled with lakes of liquid methane. And there's actually a kind of out there plan in place where NASA may attempt to send a spacecraft that has a sailboat that would be able to sail on the hostile surface of Titan, that would be able to explore those liquid methane lakes. However, one of Saturn's other moons, Enceladus, may actually support life. And this was during the Cassini mission NASA sent out for the Cassini spacecraft to orbit Saturn, to take photographs, to photograph the moons, to study all these different things. And it was able to photograph geysers firing water vapor out of its surface, this picture here. And so NASA posits on Earth, anytime that water exists, life also exists. And so NASA deduces that, the geysers on Enceladus are evidence that liquid water does exist under the surface. There's some process that allows liquid water to exist under the surface. And so therefore, under the surface of Enceladus, where there is liquid water, there may also be life. And that to me is one of the more incredible things about the planet Saturn, is that it actually harbors a moon that, right here in our own solar system, might have extraterrestrial life. We've always thought kind of, when you think of the Martian, Mars, and the evidence that there was once water on Mars, and we think that's where extraterrestrial life would be. But it's interesting to me, too, that Saturn also has a planet like this, and I think it makes me kind of believe that extraterrestrial life may be closer than we believe it to be. It may be also more prevalent than we believe it to be. We think so often of humans being a miracle, and when I think of things like Mars having liquid water at one point in time and having probably hosted life, then the possibility that a moon on Saturn also does, I think that lends a lot to the fact that maybe we aren't as rare as we believe ourselves to be. So that's what I've got for you on Saturn. Thanks, guys.